Exclusive events are events that can occur at the same time. So, for example, passing your physics test and passing your math test. Okay, being on a basketball team and on the student council. So in that case, there's this intersection of event 1 and event 2. Okay, and the addition rule for this is right here. So this is what happens. So we have the probability of A and B happening is the probability of event A plus the probability of event B. So this is just like we had in mutually exclusive events. However, now, since, I'll do this in blue, so event 1 is in blue, right? And then we added it to event 2, let's put that in purple. But the problem is, we double counted this intersection right here. So what we actually have to do, since we double counted it, we have to subtract that intersection once. So we have to subtract probability of A and B. Oh, this is or. My mistake. Probability of event A or B happening. Or. Okay, so let's do an example. Example 2. For this section, a card is randomly selected from a standard deck of cards. What is the probability of the card being either a heart or a face card? So, how many hearts are there? Well, there are 13 hearts and there are face cards. There are 3 face cards, Jack, Queen, King, and 4 suits. So there are 12 face cards. Okay, so what we actually have to think about is how many hearts and face cards are there. So how many hearts are face cards? So out of the 13, there are 3. So there are 3 that we actually double counted. And the standard deck is 52 cards. Standard deck, 52. So let's go. Probability of A or B equals probability of A, so the probability of hearts plus the probability of a face card minus the probability of a heart and a face card. Let's just change that to H and F, H or F, just so it aligns with the letters that we've been using. So the probability of a heart is 13 over 52. Probability of face card is 12 over 52. And the probability of a heart and a face card is 3 over 52. So what we're trying to do is we're going to add 13 plus 12, and we get 25, but then we have to subtract 3, so we get 22. So it's 22 over 52, which reduces to 11 over 26. That's the probability. Or we can see something in a word problem, like example 3. So there is a 60% chance that Sammy will score over 90% on his math test. Okay, so math, 60% chance that, let's call it good, so over 90%. And a 70% chance that Sammy will score over 90% on his English test. So English, and let's go 70% of him doing well again. Now there is a 30% chance that he will score over 90% on both his math and his English tests. So math and English being very good is 90%. Sorry, 30%. So let's draw a Venn diagram to display the situation and then determine the probability that Sammy will score above 90% on one of his tests. Okay, so we have Venn diagram. I like to make the intersection really good. So let's call this math and English. Okay, so we know that the intersection is going to be 30%, so 0.3. Now the math will add up to 0.6, so 0.3 plus 0.3 is 0.6. And the English will add up to 0.7, so that'll be 0.4. So here's our Venn diagram. but let's just do this, the universal set on the outside. So 4, 5, 6, 7, 8, 9, 10. Oh, that's fine. We'll leave it like that. Now, what's the probability that Sammy will score above 90% on one of his tests? So we actually can just look at this Venn diagram since we've already done all the work. So the math is 0.3, and scoring above 90% on only English is 0.4. Okay, so there's 70% chance that he will score over 90% on only, like solely one of his tests. Therefore, 0.7 probability that he will score 90% plus on one of the tests.